This video reviews voltage and current. Our textbook refers to voltage as voltage difference, which is a force that causes electrons to flow. And if we think back to the previous unit on energy, voltage difference is the potential to do work, as in potential energy. Compared to current, current is actually a rate. So it's the rate of charges that are moving through a circuit. In our circuits, those are the electrons moving through that circuit. And we can sort of consider it as charges per second as a way of thinking about the numbers we get for current. So what does this all mean? Well, let's break this down a little bit. Our textbook uses an analogy, and they show this picture to try and explain how voltage works. Here we have two containers containing water connected by a small tube. Now, there's going to be a high pressure on the left-hand side that would cause water to flow through the tube and try to equal out the amount on both sides. So this high pressure area is like an area of high voltage compared to an area of low voltage. Now, if we compare this to what we see in our definitions, there's a force here that's going to cause the water to want to go from where it's high pressure to where it's low pressure. Just like if you had a large amount of electrons on one side of a circuit, it wants to go to where it's low. So it's going to go from high to low. And you can see how this could be a potential to do work. That transfer would cause a large amount of energy to move through this tube, so you can do energy there. So the book also provides us with this diagram, which depicts the electrons as negative. Here we have a higher end of voltage and a lower end. So if this were to be a battery, this would be the negative side of the battery, and this would be the positive. Electrons would want to flow through a circuit where it would be moving to where it's highest to lowest. Thus, there's a force here that's being implemented in a battery where through the circuit, charges want to go from where it's high, negative, to where there's very little negative charge. So we end up going from where it's high voltage to where it's low voltage. Your book also provides an additional analogy. This one's very similar to our water wheel. So just like the water wheel activity, we have a storage area that's suspended high above, sort of due to gravitational potential energy. And water will flow past a wheel and come to a storage area that pumps it back up to a higher location. Now, this is, of course, an analogy. This is not depicting really how circuits work, but it also helps us to sort of think about this, though, in a way that we've already experienced in class. So the voltage difference would be from comparing where we have an area of high voltage, in our analogy would be the high point of a water tank, and comparing that to where we have low voltage, near the bottom here, where our tub would be, where we'd want to return that water. The electrons want to flow from where it's high to where it's low, but going straight down through the water tower isn't necessarily the easiest way because there has to be a path for those electrons to flow, or in this case, water has to flow. So we provided one. The circuit is the path that the water would flow in our analogy. In that circuit, which water will be flowing, is actually going to be the flow of electrons. The rate at which those electrons flow through the circuit is current. And current is going to be dependent on the resistance of the flow of electrons through the circuit. Now, if we're thinking about our analogy here, there's going to be resistance to water entering our pipe here. Maybe there's a valve that we can close off that either turns off all of the water or makes it go really, really slow. And in our current, right, in our circuits that we build, that is resistance. Anything that would slow the flow of electrons is considered a resistor. In our circuits, our electronic devices are resistance that provides some type of slowing mechanism for the electrons moving through the circuit. And all this relates back to Ohm's law, which states that a current is going to be equal to the voltage difference divided by the resistance in that current. In other words, I for current is equal to V for voltage difference divided by resistance. And the units that we get for current would be capital A for amps or amperes.